Okay, this is Miss Hamilton. We are on a new unit. Our unit is exponents and polynomials. So this is lesson 1, and we'll also be doing lesson 2 today as well. So exponents. We use exponents to represent the numbers, which can be written as repeated multiplication. So for example, 1 million could be really represented in expanded form. Okay. And we'll do a little bit of expanded form today. Okay, as 10 times 10 times 10 times 10 times 10 times 10, or if we use it exponent, we can go 10 to the power of 6. So there's a couple of elements you need to understand about exponents, okay? So this is just an example of one. So in this example, okay, 10 is our base, okay, and our exponent is 6, okay? Powers can appear in formulas in various expressions, so it's one of the reasons why we're doing exponents first, because think of order of operation, right? Bedmass there, okay? Brackets, and then what comes the next after brackets? Exponents. So if we can't solve exponents, then can we really do the rest of the math there that's required? No, so we need to have a better understanding of exponents, okay? When evaluating expressions with powers, it's important to follow the correct order of operations, just as I mentioned, okay? Okay, so what we're going to do is we're going to look at a couple of examples of bases and their exponents, and then what expanded form would look like. And when we're doing this, we're going to look at a couple of rules. So some of this will be new for some people. Some of these concepts won't be new, okay? Just depends. So what is the base of the first one, 2 to the power of 5? Who would like to tell me? Yep. Pardon? You guys speak up. 2, thank you. Okay. You guys speak loud, guys, with the mask on, okay? And the exponent is 5. Yeah, let's just yell it out. 5, okay? Oh, yeah, go for it, okay? So our expanded form is like saying 2 times 2 times 2 times 2 times 2 5 times, right? And when we evaluate that, so we can evaluate it either with a calculator using 2 to the power of 5 or 2 times 2 times 2 times 2 times 2, right? Which is 32. Okay? Now, the next two, these might be new concepts for you, okay? So what we're saying is brackets let us know what's contained in the base, okay? So for example, in this question, our base is -4, okay? Because the brackets are identifying that that is contained, okay? And that goes to the exponent of 3, okay? So we would have -4 times -4 times -4, okay? And since there's 3 negatives, what should we get? Should we get a negative or positive answer? Negative answer, and we get a negative answer of -64. Okay? Now, in the other example here, there is no brackets. So our base here is actually just 3. Okay? Our exponent is 2. Okay? Now, we still include the negative in expanded form, okay? The negative is just by itself, though. The exponent is not applied to that negative, okay? The exponent is only applied to the base of 3, okay? So here, we would assume that the negative is just -1, right? Anything without a value is still just a value of 1 if it's identified, right? Or else it would be 0, it wouldn't exist. So negative times 3 gives us -9, okay? So what I would like you guys to do is I would like you guys to try the last one by yourself, okay? So I'll pause the video. So our base is -2 over 3, okay? That's included in the brackets, okay? Our exponent is 3. And then what we can do is we can write our expanded form, -2 over 3 times -2 over 3 times -2 over 3. And it's just multiplication of fraction, right? So we just multiply all the numerators. Negative 2 times negative 2 times negative 2 gives us negative 8. And then we can multiply all the denominators. 3 times 3 times 3 is 27. Yes. Okay. So our final answer is negative 8 over 27. Okay. So this idea, this is probably new to a fair amount of people. Okay. So we're just going to summarize that idea. Okay. So remember, okay, that exponents apply to the base directly beside it. Okay. You might want to write that down. Right? Some rules. There we go. Okay. If there are no brackets around the base, then apply the exponent only to the base number. Okay? So what I would like you to do right now is I would like you to solve for negative 5 to the power of 2 in brackets and negative 5 to the power of 2 without brackets. Okay? Take a little second to try that. So what's our answer for the first one?
25.
It is 25, yeah, because we would have negative 5 times negative 5, right? Which is 25. What's the answer for the second one? Negative 25, right, because the negative out's in front. We're not really focused on it with the exponent. We're focused on 5 as the exponent. Okay, so we get negative 25. So what we're going to do, okay, is now we're going to look at expanding form when we have, essentially it's a term, okay? But we're going to look at it as separate variables in it, okay? As the coefficient or the variable. So write in expanded form, okay? What is the exponent of 4 applying to? The coefficient or the variable here? The variable. Excellent job, okay? So our expanded form, okay, looks as 3's out in front, and then we have x repeated 4 times, okay? The next one has brackets. So what is your base on that one? 3x. Yes, 3x is your base. Try that out. So for this next one, what does it look like? Just everybody yell it out together. Nope, we're not solving. What did the question ask for? Just expanded form, right?
3x times 3x times 3x times 3x.
Perfect. Excellent. So 3x times 3x times 3x times 3x. Okay. So remember, watch what the question asked for, because if you put the answer, I would be like, oh, that's not what I wanted, though. I asked for expanded form, right? So let's look at an example of a substitution question where they tell you what the variables are, their values, okay? And we plug them into the equation. So I'm going to do the first one, and then I'll have you guys do the second one, okay? So we're going to go 5, and they're replacing x with the value of 3. Use brackets, okay, when you put them in, okay? Because that's going to help you identify if there's a negative component in that, okay? Negative 3, y is negative 2 in the brackets to the power of 3, okay? Order of operations, okay? There's brackets, but the brackets aren't really around anything to be done. The first idea here is to work with the exponents, right? So we end up getting 5, and then 3 to the power of 2 is 9. Okay. Negative 2 to the power of 3 is negative 8. Okay. No division here. Multiplication's next. So I work on the multiplication. So I start with 5 times 9, which is 45. Okay. And then here, I think that this is the easier way to go about it. Always look at the coefficient, okay, if it has a negative or positive value, and use that in your operation of multiplication. So negative 3 times negative 8 becomes now positive 24. Okay? Some people will end up having negative, and then another negative value, and then they kind of get lost in what's going on instead of just being like negative 3 times negative 8, and then that just becomes a positive value, so that just becomes addition. Okay, that's just easier. Okay. We had a value of 69 here. So, question B, I would like you guys to try that one by yourself, okay? And then we're going to take it up. And essentially, we're done the first component of the lesson today. It's short. So I'm going to give you time to work on the homework, and then we're going to move into the second part of the lesson, okay? Let's take this one up. Okay, so what I'm going to do is I'm going to change some of the brackets to square brackets just so it's easier to follow along, so it's not like brackets on top of brackets, so you don't get confused here, okay? So I end up getting 4, okay, times y, which is negative 2, minus 3 to the power of 3. And all of that is to the power of 2 still, okay? So sometimes some people prefer just to do it one step at a time, but you could do a couple things at once. So I know that I could also do 4 times negative 2, which is negative 8, okay? And then I can now work on that exponent question because they didn't interact. They didn't interfere with each other, right? So 3 to the power of 3 is not 27, okay? And it's negative 27 once I drop the brackets, right? Because of that negative side note in front, okay? All of that is still to the power of 2, okay? So I get negative 8 subtract 27, which is negative 35, and negative 35 to the exponent of 2 gives us a value of 1,225, which by looking at a lot of you guys did fairly well on that, okay? Is there any questions about what I did here? Is anybody confused about anything? No? Okay, so what's going to happen, and don't worry about example 4. I am actually going to spend a whole day on word problems, so I'm not going to do this on the basic stuff because when I do the word problems, I want to do them all together, so I'm not going to teach you that concept yet, okay? So what you're going to do for homework, okay, you don't need to worry about the textbook work, okay? I've taken that out, no textbook work, because again, I only have so much time. But you are going to do the top half of the handout, and the handout is in the package. So the note package is online. I can bring up those questions right here, okay? The questions you are working on are 1, 2, 3, 4, 5, and 7, okay?
Oh.
So some of you who have printed it, have it right in your package. You can fill it out, okay? Others who have not will have to write it on a separate piece of paper to fill it out, okay? And I will leave it up here. I'm going to pause the video. Okay, guys, so we will finish off that worksheet. What we're going to be doing is we're going to be going into discovering the exponent laws, okay? So this is the second part of the lesson. Let me get this to work here, okay? So what happens when we multiply powers with the same base? So we're essentially looking at what we call the exponent laws, okay? So these are the laws you're going to need to know to be able to work through problems, okay? So say we have this product, okay? And just do an example one, okay? So 2 to the power of 3 times 2 to the power of 5, okay? Now the big thing is they have to have the same base, okay? 2 to the power of 3, 2 to the power of 5, do they have the same base?
Yes.
Okay, good. So I'm just going to quickly write expanded form, okay? So what we're really saying here is we're like going 2 times 2 times 2, all multiplied by 2 times 2 times 2 times 2 times 2, okay? And then if we were to write this as a single power, okay, our base is 2, right? How many times did I multiply 2 by itself, if now you count the expanded form? 8 times. That's right. So it'd be like saying 2 to the power of 8, okay? So what we can do here is we can add exponents together if they have the same bases, okay? we get 2 to the power of 8. Okay? So the exponent law for multiplication, okay, of powers is when you multiply, or when multiplying, so I'm going to write this law down for you guys. When multiplying powers with the same base, we add, okay, the exponents. Okay. So one of the ways we can represent this, okay, is we'll say a to the power of x multiplied by a to the power of y is really like saying a x, oh, sorry, I'm going to fix that x plus y, okay? So people get confused. It's like, okay, I'm multiplying, but I'm adding exponents, okay? So remember, multiplication happens for the bases, okay? Right, so, but the exponents will add, okay? So that kind of like mind blows some people, but that's the laws, okay? Is there any question about the first exponent law? So this is our first one. Not too bad, right? Okay. Can I move this up? Zoom in. What happens when we divide powers with the same base? Okay. So again, we're going to look at a product. Okay. Give you an example. Okay. Okay. So our product, just flip it down so you just take notes. 6 to the power of 5 divided by 6 to the power of 2. Okay? Let's look at this in expanded form. Be like saying 6 multiplied by itself 5 times. Okay? Divided by 6 multiplied by itself 2 times. And then we're going to write it as a single power. So now that it's set up in the expanded form, some of you can maybe see this. What we can do is if we have multiple things on top, on bottom, right, numerator, we can cross them out. So if one's on top, one's on the bottom, we can cross that out. Again, we have another 6, so we could cross out another 6 on both the denominator and numerator, right? So what am I left with? I'm left with 6 to the power of 3. Okay? So then what has happened here, okay, is we have subtracted the exponents from each other. Okay? And that is how we ended up with our answer of 6 to the power of 3. Okay? So the exponent law for the division of powers is when dividing powers with the same base. That's super important, right? Same base. Because there's different rules when we start to change the base you have to think about. We subtract the exponents. Okay. So if I was to write this out, I could go a to the exponent of x divided by a to the exponent of y, okay? Or it could be set up like this, just so you guys know. It could also be set up as a to the exponent of x divided by a to the exponent of y, okay? Could have it in that form, right? Is equivalent to a x subtract y in the exponents, okay? So it kind of makes it a little bit, now the rules kind of seem a little bit better. When you're multiplying same base powers, you add. Okay, when you're dividing same base powers, you can subtract the exponents. Okay? It's kind of lining up a little bit. Any questions on those so far? Because now we're going to move into some other examples, some other laws. Okay? Cameron, you writing this down? Not on the computer? Okay. I'm going to come and check your notes after. Okay. What happens when we raise a power to a power? Okay? So, sometimes you'll hear this referred to as a power of a power. Okay? So, for example, 5 to the power of 2. Okay? Oh, yeah, for sure. Come in. Okay, so 5 to the power of 2, and I'm recording at the same time. So then I send this video through explain it. I'll pause. Okay, so power to a power, so 5 to the power of 2 to the power of 4. Okay? So let's write this out in expanded form. Okay? Okay? It is like saying we are multiplying 5 to the power of 2 4 times. Okay? Right? Right? Because our base is 5 to the power of 2 in this situation. Okay? Okay? So in a single power, okay. And now if we know from the previous, okay, law, the multiplication law, 5 to the power of 2, 5 to the power of 2, 5 to the power of 2, that's multiplication. What actually happens with those exponents? Ian? Yeah, you add them, right? So you would end up getting 5 to the power of 8. But the simpler way to look at a power to a power or a raised power is like saying 2 times 4. So you would actually multiply those two together to get 5 to the power of 8. Okay? I just show the expanded form because I'm showing you the math behind it. I'm showing you the reasoning to this theory, right? So our exponent law for power of powers is when you have a power raised to another exponent or power, whatever word you want to use, okay? You multiply the exponents. Okay. So how we set up conditions for this one is a to the power of x to the power of y is really like saying ax times y in the exponents, okay? So what we're going to look at is we're going to look at a couple of questions here, okay? And we're going to try out some of our laws together. Sounds good? Okay. Just note, when they say simplify, it does not mean to evaluate. Okay, that's two different things. Evaluate, you're going to do another step. Okay, simplify is I just would like you to use the exponent laws to come up with the general new exponent. Okay? So, 4 to the power of 12 times 4 to the power of 9. I'm going to break this up. What happens with the exponents based on multiplication? What do we do to those exponents? We add them. That's right. So we would end up with 12 plus 9. Now, I don't always expect you to show me all that math, okay? Because I know you're going to be like, I know what to do with the exponents. I know to add them. You might just start to put down the answer of 4 to the power of 21. So that's just how I simplify. Now, if I asked you to evaluate, you would actually give me the answer. You'd be like, hey, what's 4 to the power of 21? And then you'd give me that answer, okay? But again, I'm asking you to simplify. So I'm just highlighting that, okay? How about you guys try B and C? We'll take those up, and then I'll do D as an example, and I'll let you try E and F, okay? So question B. I'm just going to zoom in a little bit more so I can write a little bit easier, okay? X is the same base, okay? What has happened with our exponents? What operation will happen there now if division is occurring? Someone just, yep. Subtraction. So we get 7 minus 4. We get x to the power of 3, okay? And again, I know some of you are just going to go right to the answer. That's fine. In this situation, no problem, okay? Just what happens, though, is if you make a mistake, I might not be able to give you half marks places because I didn't see why you made the mistake. That's all, okay? Question C, okay? Power to a power. We end up multiplying the powers. I like to use brackets, okay? I think you need to get in the habits of using brackets, because if you start using x starts to look like a multiplication sign, you're going to get confused. Start using brackets, okay? So 4 times 5 here, okay, is like saying m to the power of 20, okay? Now, if we were to look at D, E, and F, okay, in the order, you still want to think order of operation, okay? But does it matter if you do division or multiplication first in order of operation? It doesn't matter, right? Does it matter if you do division and addition? Which one goes first? Division goes first, right? That matters, okay? So division and multiplication, it doesn't matter. So in this situation for D, I'm just going to work from the beginning of the equation and work my ways backwards, okay? So here, we end up getting 5, okay? 2 plus 3, okay? And I'm going to just break it down even more, just to show this, okay? So 2 plus 3, okay, gives us 5 divided by 5 to the power 4, okay? Now, if I wanted to continue this on, right? Now I would have the division, and because they're dividing, same basis, we would subtract, okay? I'm just going to move this over, sorry. And I would end up with 5 to the power of 1. Do I need to show that 5 is to the power of 1? Okay. Okay. Or I could show it like that, okay? Cameron, can you put your laptop down, please? Thanks. Another way you could have done this question is you kind of could have done this in one step. Oh, I want a different color. Okay. One step, okay? I could have done 2 plus 3, and because I know there's division, they're same bases, minus 4. Okay? So some of you might have looked at it that way. That's fine. Okay? It still all ends up to the same answer. Okay? How about you guys try E and F? And then we have one more law we're going to look at. Okay? So I'm going to solve some of these questions 2 steps at a time. Okay? So for example, here, we end up getting multiplication, right? So we get 3 times 6, okay? And then on the bottom of this, what is that 5 to? What is that 5 to? What's that power, the first one? Really, what's it at? Is it 5 to the power of 0, or what is it? 5 to the power of 1, right? So that's where people, notice that. That's 5 to the power of 1. So we end up actually getting on the bottom here, 1 plus 9, okay? So then we can evaluate for the top. So we get 5 to the power of 18 over 5 to the power of 10, okay? Now we're left with division here, which means we're actually going to subtract the exponents, okay? So we are left with 5 to the power of 8, okay? So this is very important. Star that if you need to. That's 5 to the power of 1, okay? Because in my next one, F, It's going to lead me into my next exponent law. Okay, why it can't be 5 to the power 0, or what is the value of 5 to the power 0. Okay. Again, okay, we're going to start with multiplication, right? We have multiplication between the y variables here. So what happens to the exponents is they're adding, right? So we end up getting y 4 plus 3 over y 7. Okay? So we end up getting y 7 over y 7. Okay? And some of you might easily be like, oh, 7, that just would cross out, right? Okay? You can also think of it as y 7 subtract 7, okay? Which leaves me with y to the power of 0, which is going to lead me into my next law, which is anything to the exponent of 0 equals the value of 1, okay? That's going to be new for some people, okay? I don't expect you to know that. I'm going to teach that as the next law. So, what happens when the exponent is 0, okay? Well, anytime anything is to exponent of 0, it is just 1. So, any exponent to the value of 0 just equals 1, okay? Because what we're saying is it does not exist, okay? I didn't really create the lesson to go into that deep. I can for the next lesson. You want me to go into that? Yeah. Okay, I'll do that. Because actually we're going to be looking at it tomorrow in the enhanced textbook, the exponent laws. So how about I do it then? Awesome, love it. Okay, so evaluate. 3 to the power of 0, guys. 1. Negative 2 to the power of 0. Okay. 5x to the power of 0. Okay, 1. Right, because this base, this is the base. Here's 1. 5x 0. 5, yeah, right? Because the exponent only applies to, directly to the base unless it's identified by brackets, right? Okay, so don't let that one kind of confuse you, okay? So what happens when we have coefficient, base has a coefficient part and a variable part, okay? So we're going to look at a couple more examples here, okay? We're doing fairly good on time. I still have about another, I would say 15 minutes of talking. So in this situation, okay, we still have the coefficients that can work here. So we still have 3 and 4. And what is the operation between 3 and 4 that's happening? Pardon? They're multiplying, right? That's what a bracket's identifying. So 3 and 4 are still multiplying, okay? And then our exponents are x2 and x5, right? Do they have the same base? Yeah, so then we can do some work. So let's look at this. So what's 3 times 4? 12, so I dealt with that, okay? x2 times x5, right? Our exponents would add together. So my final answer looks as 12x to the exponent of 7. Okay. So what I always recommend people to do is kind of work with the coefficient first, then you can work with the exponent. Just kind of work in that order, okay? I'm going to zoom in, okay? Let's do this without having to write this all down, okay? 30 divided by negative 2. Negative 15. Thank you, okay? Y13 divided by Y5, what actually happens? Subtraction. So I'll show that though. So Y13 subtract 5, right? Okay. Our final answer is negative 15 y to the power of 8. Okay. Example 3. This is what you need to note, okay? That 2 is in a bracket as well. So it also applies to the exponent law of 3, at least in this situation. Okay? So 2 to the power of 3 gives me a value of 8. Okay? And then m is my base. right? 4 to the exponent of 3 is actually like multiplying the 2, right? I should put 4 first, sorry. Okay. So we get 8m to the power of 12. Okay. So little rule, we can just say solve the coefficient and then solve exponents with the same base, okay? So now we have a bunch of laws. We have what to do with coefficients, we have power to power, we have multiplication, we have to the power of 0, we have, so we have them all. So what we can do is we can evaluate a little bit more complex problems here, okay? I'll do the first one, you'll do the second one, I'll do the third one, you'll do the fourth one, and then we're gonna call it a lesson. I've done a lot of talking so far, 36 minutes, okay? So, I'm gonna try to do this more by how I think you guys are gonna do this, okay? Because I don't expect you guys are gonna write 2 times 8, negative 8. So, I'm gonna start with the coefficients. 2 times negative 8 is negative 16, okay? My base is x. 5 and 6 are multiplying by each other, so they're actually adding.
Wait, so we do 2 times negative 8, and then we do x. Okay.
x5 times x6,
Right.
but what happens with exponents? Because they're multiplying.
Multiply them.
Nope.
You just add them.
Yes. So this is where people get confused because they're like, okay, but you're multiplying the coefficients, but you're adding the exponents. Yes. You've got to break it down. You got to think about it as 2 separate rules, okay? Yes. X to the power of 11, okay? So guys, try B. Try B and then complicated. So we're going to start with the coefficients. What is negative 22 divided by 11? Negative 2, okay? Now, you have to focus on the exponents here. So V, 9, subtract 4, okay? W, 4, subtract 3, okay? So my final answer, V to the power of 5, and then W, some of you might put W to the power of 1. It's not wrong. I'm not going to take marks off you for putting W to the power of 1. I just am going to show it as W because that's just like extra math, okay? Let's look at C together, okay? And then I'll have you try D last. Can I zoom in into C? Is everybody fine with that? Okay. So again, I'm going to do a couple of steps at once, okay? So I like to start with the coefficient, and I like to start on top, like in the numerator position if I'm looking really at like a fraction, or even though it's a division question. 6 to the power of 2 is 36, right? X, 7 times 2, right, is 14. And that's kind of how I expect you guys are going to do some more of this. Instead of writing out 7 times 2, you're probably going to do 7 times 2 is 14. Write that down, okay? Now I'm going to look at the bottom. 2 times 9 is 18, okay? X2 times X1, X3. That's right, because they add, okay? Now I have something that's a little bit nicer to work with. I start with the coefficients again. 36 divided by 18 is 2. So I started there, okay? And then because the basis it's x, right? 14 subtract 3. 11. Okay? Yeah, so now I'm showing you how you can get a little quicker in the math. I'm not showing every detailed step. I'm just showing you how you can make these a little quicker. Okay? Last question here. Try D, and then we'll take that up. Good? Okay. Just going to zoom in. Okay. So we have to start with the coefficients, but we have to start with the exponent first, right? So 6 to the exponent of 4 is? You could do it that way too. You could work it. I'm just gonna take the long way. How about that? You want to simplify it first? You guys rather? Okay, let's do it that way. I'm cool with that. 2 ways to do it, just in case someone else did it the other way. Okay, so we're going to start with the coefficients. So 6 divided by -3. -2. Okay? So I'm going to highlight that just so my other people at home know what we're doing. Okay? 8 subtract A7, right? Is just going to leave me with value of A. Right? I'm just going to leave it as A. I'm just going to leave it as A. Okay? B5 essentially is subtracting B2 is going to leave me with a value of B3. All to the exponent of 4. Okay. So -2 to the exponent of 4 is? Is it 16 or -16? 16. It's 16, right? Because the negative is included in the bracket, right? That's why. Okay, so it's 16, positive value. Okay, a to the exponent of 4 is? Yes, a to the power of 4, right? Because we're not saying 0 times 4. We're saying 1 times 4. Okay, b to the power of 3 times to the power of 4 is? B12. Yeah, B12. Take your vitamins, kids. Okay, that's a good one. Okay, so you don't have to do the textbook work. Look at that. Ms. Hamilton's being super, super, super nice. But you must complete the rest of that handout. See how it said from yesterday? That's a normal course. We're not doing a normal course. We're doing a short course, so that's why. So you need to go back to this worksheet. It is in the package. Okay? And you are finishing that whole worksheet for homework. Okay? Okay? But the next time I see you.
That's nice.
When I see you next, that's when I'm going to check. You should really have it done for tomorrow because we're moving on. Yeah, you're going to do all of it now. All of it.
I can't see it.
Okay? It's on. Did you bring a device?
It's still can't connect.
Okay.
What?
I have a sheet
What is?
you can look at.
It doesn't work. PDS for iPhones.
No, you can use PDS.
We'll get someone to help you. Okay? So the rest of this is homework.